Today's lesson is a review of rational functions. The purpose of this is because starting next week in our next section, we are going to be looking at functions algebraically instead of graphically. So we need to be able to take a function that in algebraic form and then decide what that graph looks like or what might be occurring at certain spots like holes or vertical asymptotes or horizontal asymptotes or things of that nature. So we need to kind of go back over the properties of these rational functions and so that we can understand how these functions look. So if you will remember, we have three different kind of things that happen with a rational function in terms of factoring it. You either might have a hole, a vertical asymptote, or an x-intercept. So holes occur when their factor is in both the numerator and the denominator. Vertical asymptotes occur when the factor is only in the denominator, and then x-intercepts would be when the factor is only in the numerator, or in other words, when the numerator equals 0, or when the denominator equals 0, or when the numerator and the denominator both equal 0. So let's take a look at some we'll go to some examples in a second, but the second feature that we want to look at are horizontal asymptotes, and in that case there was three scenarios. The first scenario, and we always look at the degree. So in the first scenario, the degrees are the same. So looking at this example, we can see that the degrees of both of these are cubics. And if that's the case, then we go to the leading coefficients. So in this case, 4 and 3 are the leading coefficients. So the horizontal asymptote of this would be y equals 4/3. So looking at a graph, if we are at a graph, we got 1, we got 2, 4/3 is somewhere in between there. So there would be our horizontal asymptote. Scenario 2 is when the top degree is smaller than the bottom degree. So in this example, the top degree is a cubic, the bottom degree is a quartic, 3 being smaller than 4. In that case, it's automatically y equals 0. So we don't look at leading coefficients in this case, it's just automatically 0. And then the example there would be that our horizontal asymptote would be the x-axis. Finally, scenario 3 is when the degree on top is higher or larger than the degree on bottom. So in our example, a quartic on top, a cubic on bottom. In that case, there is no horizontal asymptote. There is a slant asymptote. So the slant asymptote, which we're not really worried about finding, might look like this. So the graph might be something like this, where the graph gets closer and closer to that slant asymptote but never touches. And then there would be no horizontal asymptote. All right, so let's go through some examples. We're going to need to remember how to factor. If you need practice with factoring, then that's something that you might want to look up on your own. I'm going to kind of go through these relatively quickly so that we're not wasting time factoring, but remembering how the different features look. So in this case, the one on top cannot be factored. In the bottom, the first thing I can do is factor out a greatest common factor, which would leave x squared plus x minus 6, which can be factored further to be x plus 3, x minus 2. So the first feature that we said that we look for are the holes. That's when the factor is in top and bottom. That does not happen, so there are no holes. The next thing we would want to look at are the x-intercepts. In this case, that was when the top is 0. Well, the top in this case is always 1, so that never happens. No x-intercepts. The next thing would be vertical asymptotes. That is when the bottom factor is equal to 0. That happens twice. In this case, that happens when x is negative 3 and when x is 2. And finally, horizontal asymptotes follows one of the three scenarios. In this case, the bottom degree is larger, which means that it's automatically y equals 0. So the next thing we're going to do is take that information, use it to sketch a graph. So in this case, we're going to look at the horizontal asymptote is y equals 0. The vertical asymptote is at negative 3 and at positive 2. There are no x-intercepts and there are no holes. So this graph never crosses the x-axis. This graph also never crosses, it does cross the y-axis, but we're not going to get there. So the next thing we want to do is we just want to test a few points. You can also use Desmos, but in calculus sometimes there's going to be no calculator problems. So you're going to need to be able to kind of do this on your own without using Desmos or graphing calculator. So what you're going to want to do is you're going to want to test a point that's in each one of these sections, and that's going to help you decide if the graph is above the x-axis or below the x-axis or below the horizontal asymptote. So looking in this section here, I'm going to choose a point like -5, plug it in, and I'm going to plug it into this equation because that's going to tell me positives and negatives. So in this case, when I plug in a -5, I get a positive value on top, a 1, that's always positive. 3 is always positive. -5 plus 3 is going to be a negative value, and -5 minus 2 is also going to be a negative value. So when I multiply all that out, I end up with a positive result, which means that my graph has to be above there. In between, I'm going to try 0. So I'm going to test f of 0. In this case, again, 1 is always positive, 3 is always positive, 0 plus 3 is positive, 0 minus 2 is negative. So when I multiply all that out, I end up with a negative value. And then likewise, try a positive 5, something in this range over here. So when I plug in a positive 5, it could be any value that's more than 2, but I'm just going to use 5. Again, I end up with a positive 1, a positive 3. When I test in the first factor, 5 plus 3 is positive, and 5 minus 2 is also positive. And when I multiply all that out, I end up with a positive value, which would be there. So that's a good idea of what your graph looks like. Now that I know what my graph looks like, I can evaluate limits more easily. Okay, let's look at example 2. In example 2, same thing, no factoring to do here, so this one should be pretty straightforward. No holes, because there's no factors in top and bottom. X-intercept of 2, vertical asymptote at 4, and the horizontal asymptote would be y equals 1. And let's go through those. Again, holes, there are no holes because there are no factors that occur in the top and the bottom. X-intercepts would be 2 because that's what makes that top factor equal to 0. Vertical asymptote would be 4 because that's what makes the bottom factor equal to 0. And then because the degrees are both the same, we look at the leading coefficients, in this case 1s, and we get 1 divided by 1, which is 1. So now I can use that information to graph vertical asymptote at 4, horizontal asymptote at 1, x-intercept at 2, and then that should be enough to graph. So because I have a point underneath the horizontal asymptote on this side of the vertical asymptote, I know that the graph has to go like that, so I don't even need to test a point. I'm going to go ahead and test a point here. So in this case, I'm going to plug in a 5. This time I need to know an actual number because I need to know if it's above or below this horizontal asymptote of 1. So when I plug in a 5, I get 3 divided by 1, which is 3. So I know at f of 5, my function value is at 3, which means that my graph has to be above that horizontal asymptote, which again is enough to go ahead and graph that. And then that would leave me with enough information to tell limits at asymptotes, either horizontal or vertical.